Hi, I'm Mary Antonette from Ramy Learning Centre. I'm doing a series of classes for Engineering Mathematics first year covering concepts and problems. Let us first start with the basics of limit of a function. Can you see this bat ready to strike the ball? At time t, the ball and the bat approach each other from either side along a particular path to meet at a particular point. This path is a function of t and this point is t comma f of t. Look at this graph. As t approaches 2 from either side, f of t approaches 7. This is an analogy for limits. Limits is all about how a curve behaves when a variable approaches or tends to a particular value. Let us look at this function f of x is equal to 2x plus 3. We'll see how this curve behaves when x approaches 2. As x approaches 2 from the left as well as from the right, we find that f of x approaches the value 7. See, it approaches the value 7. Now we call the value of y as f of x and this equation as f of x is equal to 2x plus 3. Why? Because y is actually a function of x. So f of x is nothing but the value of y, and here as x approaches 2, the value of y approaches 7 from either side. Therefore, the limit of this function is the value that f of x approaches. So here the limit of this function is 7. Now let us see the limit of the function numerically. I have actually jotted down a few values of x and the corresponding values of f of x from the left as well as from the right. We find that from the left, as x gets closer and closer to 2, f of x gets closer and closer to 7 from the left. For the same function f of x is equal to 2x plus 3. And the same thing happens along the right hand side also. As it approaches 2, that is as x approaches 2, function f of x approaches the value 7. Let us look at another function f of x is equal to sin x by x. Let us see how this curve behaves at x is equal to 0. When I substitute the value 0 in f of x, I find that it is equal to 0 by 0. Therefore, f of 0 is not defined along the curve. Therefore, it creates a hole on the curve. But let us see how this function behaves. Now, as x approaches 0 from the left as well as from the right, f of x approaches 1, though 1 is not on the curve. The point 0, 1 is not on the curve, and f of x does not belong to the curve. But the limit of f of x as x approaches 0 is actually 1. Let us look at the definition of a limit of a function. We know that the limit of a function is the value that f of x approaches when x approaches a particular value for a given function. Now let a and l be any two real numbers. As x approaches a, we find that f of x approaches l. Or as x tends to a, f of x tends to l for this given curve. This is expressed as limit x tending to a of f of x is equal to l. Before we move on to the next definition of a limit, let us look at the neighborhood of a point. We know that the neighborhood of a house is the area that surrounds the house with other buildings and houses on it. Similarly, the neighborhood of a point is a set of points that lie very close to the point whose maximum distance is less than or equal to a very small number. What is the neighborhood of a point on the number line? The neighborhood of a point A on the number line is a set of points that lie very close to A along the line. They actually cover an interval, and the length of this interval is a very small number. And what is the neighborhood of a point on the plane? The neighborhood of this point on the plane is a set of points that lie around A. These points, they lie within and on the circle, where the radius of this circle is a very small number. What is the neighborhood of a point in 3D space? Let A be the point in 3D space. The neighborhood of this point A is a set of points around A. Since it is in 3D space, these points lie within a sphere, and the radius of the sphere is a very, very small number. Let us now define limit in an alternate way. Consider the expression limit x tending to a of f of x is equal to L. Let us derive an alternate expression for x tending to a. Let a be a point on the x-axis. Let x be a point in the neighborhood of a on the axis. Let f of x be a function of x. Let delta be a very small number. As x approaches a from the left, we have a minus x is greater than 0 and less than delta. As x approaches a from the right, we have x minus a is greater than 0 and less than delta. What does this mean? This means that x is very close to a, but it's not equal to a. For if a minus x is equal to 0, then x is equal to a. This means that x and a are different points. So it is a very small length, a minus x and x minus a. They are very small lengths, okay, which is less than delta. Now, since a minus x and x minus a are lengths, we can replace them by modulus of x minus a. So here we have x minus a tends to a can be alternately written as modulus of x minus a is greater than 0 and less than delta. Let us now find an alternate expression for f of x is equal to L. Let L be a point on the y-axis. Let f of x be a point in the neighborhood of L on the axis. Let epsilon be a very small number. As f of x approaches L from the left, we have L minus f of x is less than epsilon. As f of x approaches L from the right, we have f of x minus L is less than epsilon. Since both L minus f of x and f of x minus L are lengths, we can replace them with modulus of f of x minus L. Or in other words, we have modulus of f of x minus L is less than epsilon. So the second definition of a limit goes like this. Let f be a function defined on an open interval that contains a. What do you mean by an open interval? An interval which does not include the endpoints. Then, for every epsilon greater than 0 and every delta greater than 0, we know that epsilon and delta are very small numbers. Okay, epsilon and delta are infinitesimally small, such that if modulus of x minus a is less than delta, then modulus of f of x minus L is less than epsilon. Let us look at a few problems. What is meant by limit x tending to 5 of f of x is equal to 9? It means that the limit of f of x as x approaches 5 is 9. Is it possible to have limit x tending to 10 of f of x is equal to 1 and f of 10 is equal to minus 2? That is, when you substitute 10 in f of x, it is equal to minus 2, but the limit is minus 1. Yes, the limit of f of x as x approaches 10, that is minus 1, can be different from the value of f of x at x is equal to 10. Express if modulus of x minus 4 is greater than 0 and less than epsilon, then modulus of f of x is less than 11 in the limit form. Limit extending to 4 of f of x is equal to 11. If you would like to receive regular updates about the classes, subscribe and hit the bell icon.